ISO 42001 Annex controls can feel abstract until we ask one practical question. What must the AI system actually do? In this topic, we'll translate governance intent into architecture, implementation controls, and evidence that can stand up to certification. So far, we've built the foundation. Why ISO IEC 42001 exists, how an AIMS follows the ISO management system model, and how scope and inventory define boundaries. Now we'll turn that foundation into a practical interpretation of Annex controls. Annex controls matter because they translate management expectations into engineering decisions. They turn policy intent into platform requirements, workflow gates, integration patterns, monitoring signals, and evidence trails. For AI architects, these controls are not a compliance checklist added at the end. They become design drivers across development, deployment, testing, and governance. Embedded this way, assurance becomes repeatable, audits become easier, and risk management becomes part of how the AI system operates. One useful way to apply ISO 42001 controls is to think in themes. Policy sets direction. Roles create accountability. Risk and impact assessment identify where stronger safeguards are needed. Data governance, lifecycle management, third-party oversight, and monitoring then turn those decisions into day-to-day controls. For architects, the practical question is, which themes change platform capabilities, deployment patterns, integrations, or operations? Grouping controls this way turns a complex annex into manageable workstreams. Policy becomes real only when it changes how systems are designed and operated. Rules about approved model types, data use, explainability, and human oversight should translate into architecture standards and platform controls. In practice, that means approval gates, access controls, configuration baselines, guardrails, and automated checks. Governance workflows also need exception handling, escalation, and decision logging. The test is evidence. Model cards, audit logs, and policy as code, showing that expectations are operational, not just written down. Accountability in AI cannot be informal. Each lifecycle stage needs a named owner for action, approval, risk, and evidence. A RACI-style model helps separate who does the work, who is accountable, who must be consulted, and who is simply informed. Architecture should enforce those responsibilities through access controls, approval workflows, segregation of duties, and decision logs. When ownership is unclear, audits fail, issues linger, and supplier handoffs become risky. Risk management becomes architectural when each AI risk turns into a design decision. Start by naming risks such as bias, privacy leakage, drift, hallucination, or unsafe automation. Then assess impact and likelihood. Choose a treatment. Avoid, mitigate, transfer, accept, or require more assurance. From there, implement controls such as validation pipelines, prompt filters, safety classifiers, access limits, fallbacks, and monitoring. What matters is traceability from risk statement to control, to test evidence, to live metrics. Impact assessment turns abstract AI risk into concrete design obligations. Before deployment, ask who is affected, what benefits are intended, what harms are plausible, and which safeguards are required. Those answers should flow directly into architecture. Transparency, explanations, appeal paths, monitoring, and human review. For high-impact uses, raise the bar with stronger evidence, stricter approvals, and clearer accountability. Then revisit the assessment whenever data, models, context, or stakeholder exposure changes. Data governance is not a one-time approval before training. It travels with the data. At ingestion, confirm provenance, consent, and authorization. During preparation, enforce quality checks, labeling standards, privacy controls, and access limits. Training, validation, testing, production, monitoring, and feedback data each need distinct rules because they carry different risks. Evidence matters here as well. Inventories, lineage records, dataset approvals, quality reports, access reviews, and audit logs show that the controls are actually operating. Lifecycle controls turn AI governance into a repeatable operating model. Every system should move through clear gates: concept, design, build, validation, deployment, operation, and eventually change or retirement. At each gate, teams confirm criteria, approvals, evidence, and rollback options. This applies beyond the model itself, including prompts, data, pipelines, APIs, infrastructure, and integrations. The aim is simple: prevent unmanaged experiments from quietly becoming production risk. Modern AI systems rarely stand alone. They rely on model providers, data vendors, APIs, cloud services, and outsourced teams. So control has to extend beyond your own environment. Begin with due diligence, then make obligations explicit in contracts, security requirements, service levels, change notices, and incident reporting. Keep evidence current through assessments, model documentation, reports, and monitoring metrics. Just as importantly, document shared responsibility boundaries and define an exit path before a supplier becomes critical. After deployment, monitoring becomes the control loop that keeps an AI system trustworthy. It should watch model performance, drift, bias signals, security events, user feedback, incidents, and compliance with policy. Dashboards translate those signals for two audiences: engineers who operate the system and governance teams who need oversight. When thresholds are crossed, predefined actions follow: investigate, roll back, retrain, escalate, or suspend. The goal is not reporting for its own sake. It is continual improvement. To translate a control, start with intent. What risk should this control reduce, and what outcome must it prove? Then link that risk to concrete capabilities, such as registries, approval workflows, audit logs, access controls, and monitoring. Define the implementation pattern: owner, evidence source, and test method. For example, model approval before production becomes a gated deployment workflow, recorded approvals, and an audit test that verifies no model bypassed review. This is how governance becomes enforceable architecture. Control selection is not a checkbox exercise. Ask whether each Annex control fits your AMS scope, AI system type, deployment context, risks, legal duties, and supplier dependencies. If it applies, define the architectural capability, assign an owner, and identify evidence. If it does not apply, record a risk-based justification. The result should be traceability. Every risk connects to a control, design decision, test, monitoring result, and audit record. Annex controls matter when you translate them into architecture: clear obligations, safeguards, governance practices, and evidence. Treat them as design inputs, not checklist items. The central discipline is traceability from risks, to controls, to decisions, to proof. Next, we extend this foundation into AI governance, risk, and compliance architecture.